rapid access to comprehensive oncology data and survival analysis. This is the Onco Toolkit.
In the world of oncology, there's this one question that's always been at the heart of everything. It's a tough one. And today, we're going to dive into the decades-long fight to find an answer, specifically when it comes to a type of cancer called DLBCL. I mean, think about it. How do you predict the future for a cancer patient? It's a question that hits hard, right? It's not just an abstract medical problem. It's deeply personal for patients, for their families, and honestly for the doctors trying to make the best possible decisions. For so long, prognosis, that's the technical term for it, felt more like an art than a science. But that's exactly what we're talking about today, the push to turn that art into a science.
Okay, so let's start with what we're calling the Prognostic Puzzle. So we're zeroing in on a specific cancer, Diffuse Large B-Cell Lymphoma. You'll hear it called DLBCL for short. Now, this is the most common type of non-Hodgkin lymphoma, but here's the kicker. It's a real chameleon. For some people, standard treatment works and they're cured. But for others, maybe even up to half, the cancer comes back. You've got the same diagnosis, but wildly different outcomes. And that unpredictability, well, that's what makes it such a huge puzzle for doctors.
So how do you even begin to solve a puzzle like this? Well, researchers came up with something called a Prognostic Index. And honestly, the best way to think about it is like a scorecard. You look at a bunch of different factors, some about the patient, some about the cancer itself, and you add up the points. This gives doctors a statistical best guess, an estimate of what's likely to happen. It's really the first step toward making treatment less one-size-fits-all and more personalized.
And the first big game-changing moment in this whole story, it happened back in 1993. It set a benchmark for everything that followed. And this was it, the International Prognostic Index, or IPI. And you really can't overstate this. It was absolutely revolutionary. For the very first time, doctors everywhere had a single, standardized way to assess risk. It was built on 5 pretty straightforward factors. How old is the patient? What's their level of a blood marker called LDH, which basically hints at tissue damage? How are they doing physically, their performance status? What's the stage of the cancer? And has it spread to places outside the lymph nodes? Simple questions, powerful tool.
So what was the big deal? Well, look at this number. With this new IPI tool, doctors could now clearly identify a high-risk group. And for them, the 5-year survival rate was just 26%. Let's be clear, that is a gut punch of a number. It's stark. But having that information, as hard as it was absolutely critical. It meant you could start tailoring treatments for the people who needed it most. But here's the thing about medicine. It never stands still. Just as this tool was becoming the gold standard, a new treatment came along and basically turned the whole board upside down. This was the Rituximab Revolution. And this is such an interesting twist, right? A huge success in treatment actually created a brand new problem for prediction. See, this drug, Rituximab, was an immunotherapy that when you added it to chemo worked wonders. I mean, it dramatically improved survival for pretty much everyone, which is amazing, fantastic news for patients, obviously. But for our trusty IPI scorecard, it kind of broke it. The tool's ability to pick out that highest risk group got, well, blurry. The lines it used to draw so clearly just weren't there anymore. And you don't have to take my word for it. The clinical reports from that period say it plain as day. The IPI's usefulness for prediction just wasn't what it used to be, all thanks to these new, better treatments. So the tool that had been the North Star for doctors for years was suddenly less reliable. It was time for an upgrade. So what happens next? Well, you have to evolve, and that's exactly what the medical community did. It was time to build a better index for a new era. Enter the NCCN IPI. This was the first major revision, and it was all about getting more specific. It's like going from a blurry photo to a high-resolution one. Instead of a simple over or under 60 for age, it split it into 4 distinct groups. For that LDH blood marker, it wasn't just high anymore, it was how high. And it also got smarter about where the cancer was, recognizing that having it in specific places, like the brain or spinal cord, was a much bigger deal. It was all about adding this granularity, this finer detail to get that predictive power back. But of course, the story doesn't end there. Science is never satisfied, right? The NCCN IPI was a huge step forward. But to get even more accurate, to get even closer to a truly personalized prediction, everyone knew the next step was to look for even more factors. And this led to this boom of even more specialized indices.
You had things like the GLTAMO IPI, which took the NCCN IPI and added yet another blood marker for extra precision. And then something really important happened, the Geriatric Prognostic Index. This was a huge deal because it acknowledged that for older patients, say over 70, the standard factors aren't the whole story. You also have to ask, how are they managing day to day? What other health issues are they dealing with? It's a much more holistic view for a specific population. Okay, so we have the IPI, the NCCN IPI, the GLTAMO IPI, the geriatric one. You see where this is going, right? How on earth is a busy doctor supposed to manage all of that? Well, that's where the modern digital toolkit comes in.
Look, all this progress is fantastic, but it's created a new challenge: complexity. A doctor now has all these incredibly powerful scoring systems at their fingertips, but each one is slightly different. What they really need is a way to pull it all together, to process all that data on the spot, without missing a beat.
And voila, here's the solution. This is where platforms like Toolkit come into play. Think of them as super smart, automated clinical calculators. A doctor can just plug in the patient's information one time and bam! The platform instantly calculates the score for all these different indices we've been talking about. It can even spit out survival curves. All that complex history, all that research we just walked through is transformed into a clear, usable insight. Right there, right then.
So, we've come a long way, but what's next? Where is all of this headed? Well, the next chapter is about forecasting the future in a totally new way. The really big paradigm shift that's happening right now is moving away from a single snapshot in time. See, all the indices we just talked about, they give you a prediction at the moment of diagnosis, but the goal is to turn that snapshot into a movie. We want to create a continuous feedback loop, to use new tech to watch the disease and tweak treatments as we go, in real time. Which brings us to this final, really exciting question. There are these incredible new tools on the horizon, like circulating tumor DNA, ctDNA for short. Basically, we can now find tiny fragments of cancer DNA, like little breadcrumbs, just from a simple blood test. Imagine what that means. A doctor could see in real time if a treatment is working, or catch a relapse way, way earlier than ever before. So as these tools become a part of everyday care, are we finally making the leap from prognosis, which is about the average outcome for a group of patients, to true, honest-to-goodness prediction for one single individual person? It's a future that feels like it's getting closer every single day.